We're going to graph linear functions in this lesson. So here are 3 things I want you to look for as we're modeling the problem. 1, that I can accurately complete a table when given an equation, and that means using substitution to evaluate that equation. And finally, how I can plot the points precisely on a grid. These are all things we've done before, so it'll feel a little bit like review, but it will be very helpful for the rest of this unit. In today's lesson, we're going to look at some equations and we're going to do some graphing. That's going to be our big goal for today. We're going to see if we can take this function and actually graph them out. And we're going to use a lot of what we already know about these equations to make a prediction. So let's start there. We're going to complete the table and we're going to graph the line for the equation y equals negative 2x plus 1. So what do we know about y equals negative 2x plus 1? We know our slope function y equals mx plus b. So we know what our m is. M is negative 2. So what does that mean? That means, I'm going to put it into fractional form, negative 2 over 1. That means my change in y, I'm going to go down 2, and my change in x, I'm just going to move over 1. That's all it means. I'm going to go down 2 over 1, down 2 over 1. So that's going to be my slope. And my b gives you my intercept. So my b is 1. So that gives me a point when x is 0, y is 1. That gives me a starting point. So before I even do anything, I can put these first ones in. When x is 0, y equals 1. So I have my first coordinate right here. And why does this make sense? We already know this because I have negative 2 times 0 plus 1. Because we multiply, these are going to cancel out, so I'm only going to have the 1. So I'm going to just have that first piece, 0, 1. Actually, let's wrap it in red. Here's my intercept. It's right there on the y-axis. And all we have to do, Math Marvels, we can just add some quick points. So 1, 2, 3, 4. We can just put these in here and we can just figure out what the next points are going to be. But we know what the pattern is going to be. Our pattern is going to be multiply by negative 2, add 1. That's going to be our pattern. So 1 times negative 2 is negative 2 plus 1. Negative 2 plus 1 is negative 1. It's just going to be 1, negative 1. So 1, I move over to 1, and I go down to negative 1. And think about what's happening between these 2 points. I'm going down 2 over 1. Where have we seen this before? Right here in our slope. Our slope is negative 2 or negative 2 over 1, down 2 over 1. So I could even, without even evaluating this, I know my next point is going to go down 2 and over 1. I know that this is going to be its pathway, down 2 and over 1. Down 2 over 1, down 2 over 1. So let's prove it algebraically. So negative 2 times 2 plus 1. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. So here's our next point, which would be 2, negative 3, which, yes, 2, negative 3. Here's our point. So I could actually, again, we can use this. We can continue looking at the table and you can start looking at the pattern. So what is happening? We know this. So as this increases by 1, what's going to happen to our y? Look at your slope. It will tell you it is decreasing by 2. So it's going to keep going down by 2. So I'm going to predict that my next 2 are going to be negative 5 and negative 7. Let's prove it algebraically. So negative 2 times 3 is negative 6. Negative 6 plus 1 is negative 5. So it absolutely works. So our next point is 3, negative 5. Which does go down 2 over 1. And our last one, oops, I like to be consistent with my colors. -2 times 4 is -8. -8 plus 1 is -7. So our next point is 4, -7. So 4 and -7. And you can see it's still going down 2 over 1, down 2 over 1. Now, I could also go in the opposite direction, and I would know the next point would be down 2 over 1 or over 1. I can go backwards to plot the other ones. Over 1. And I know it's going to go down 2 from here. Over 1. And down 2 from here. So here we go, Math Marbles. I can actually graph all my points. Let's make it into a line. There you go. And look what I did. I was able to make a connection. I'm seeing patterns between my equation. My equation tells me my path of my line by using my slope. And again, this is when I have an equation in y equals mx plus b form. So I can see my m tells me how I am moving. I am moving down 2 over 1. Whatever that number is, that is the pathway of your points. And my b is going to tell me my intercept. It's going to tell me where that point is, starting from right over here. And if this is still a challenge part for you, you can just evaluate. You can just take your equation and just substitute for x to figure out what y is, and you can see the points as well. So this is just a great way to tie in all together. This should all start to make sense to you, and it should feel, when we talk about linear equations, we can see the equation, we should be able to predict what was going to happen in our graph. We should be able to see it, and we can see that pattern happening on our tables as well. So hit pause, jot this down. And let's go on to our next one. All right, we're going to start with our equation, which is already written in y equals mx plus b form. So I know my b is my y-intercept. And since my b is 1, I know my first coordinate is 0, 1. And that makes a lot of sense because when I substitute into 2/3 x plus 1, 2/3 times 0 is just 0 plus 1 leaves me with 1. So that's easy enough to see. Because I have a fractional form, I'm going to use certain numbers here. I want to use numbers 3 and 6, and you're going to see why when I work out the fraction. And I'm going to use -3 and -6. All right, so let's start with the first one. Let's substitute 2/3 times 3, or 3 over 1, plus 1. All right, 2/3 times 3 over 1 is the same as 6 over 3 plus 1. 6 over 3 is 2. 2 plus 1 is 3. So my next point is 3, 3. I'll do the same thing with 6. And that gives me 12 over 3 plus 1. Or 12 over 3 is 4. 4 plus 1 is 5. So my next point is 6, 5. And something I kind of just want to note, take a look at the difference between these points. I'm just going up 2 over 3, up 2 over 3. And where else do we see 2 over 3? Right here in our equation. That's our slope. So that's what's telling us up 2 over 3, up 2 over 3. So I'm actually going to do a guesstimate down 2 over 3 so you can see what our next point should be, and we'll verify it. And down 2 over 1, 2, 3 again. So let's verify these points and see if they have the same slope. I'm going to do -3, -3 over 1, plus 1, and that's going to give us -6/3 plus 1. So let's see, that's -2 plus 1 is -1. And what do you see? this point is at negative 3, 1. So that one is verified. And we'll do the same thing on the other side when we multiply 2/3 times negative 6 over 1 plus 1. Luckily, I have a little bit of space here. So that gives us negative 12 over 3 plus 1, or negative 4 plus 1, which is negative 3. So here's our last point, negative 6, negative 3. And yep, this one's confirmed too. So there you go, Math Marvels. Just the biggest takeaway is I can use my equation to figure out my first point. If you can find the b in your y equals mx plus b, you have your first point. That'll be just 0b. There you go. And then I'm just using substitution. Because I had a fraction, notice how, because I knew this was 2 over 3, I used numbers with 3's in them. Because I knew that when I multiplied, I would be able to divide by 3 pretty easily and I'd have whole numbers. And my last takeaway, noticing that our slope 2 over 3, 2 over 3, 2 over 3, 2 over 3 was the same as the slope in our equation. So that's it for today, Math Marvels. I hope this was really helpful in terms of using our table to graph points on the equation. I will see you in the next lesson. Be well.